Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Bitwise XOR of all pairings, Leetcode 2425. In this problem, we are given two zero-indexed arrays, nums1 and nums2, consisting of non-negative integers. There exists another array, nums3, which contains a bitwise XOR of all pairings of integers between nums1 and nums2. That is, every integer in nums1 is paired with every integer in nums2 exactly once, and we should return the bitwise XOR of all integers in nums3. Now let's try to understand this problem with the example. Then in example 1, nums1 has elements 2, 1 and 3 and nums2 has elements 10, 2, 5 and 0. So we perform the Cartesian product between these two numbers. That is, we perform the pairwise XOR between the numbers in nums1 and nums2. For example, we take the number 2 and pairwise XOR it with all the elements in nums2. So we perform 2 XOR 10, 2 XOR 2, 2 XOR 5, 2 XOR 0. Similarly, we will do the same thing for other elements in nums1 and nums2. So because of this, we will get a total pair of 12 elements, which we get by multiplying the sizes of nums1 and nums2. And when we XOR 2 bits, the result is 1 if the bits are different, but 0 if the bits are same. For example, 0 XOR 0 is equal to 0, 1 XOR 1 is also 0, 0 XOR 1 is 1, and 1 XOR 0 is also 1. So now let's run through this example. I have marked elements from nums1 in blue and elements in nums2 in green. So first we will perform 2 XOR 10. Binary representation for 2 is 0010 and for 10 is 1010. Now we perform bitwise XOR. At the 0th position, 0 XOR 0 will give us 0. At bit position 1, 1 XOR 1 will give us 0. Then at bit position 2, 0 XOR 0 will give us 0. And finally at the bit position 3, 0 XOR 1 will give us 1. And now we get the number 1000 in binary, which is 8 in decimal. Similarly, we will perform pairwise XOR between rest of the elements. So 2 XOR 2 will give us 0, 2 XOR 5 will give us 7, 2 XOR 0 is equal to 2, and likewise for rest of the elements. Now we got the pairwise XOR between all the elements in nums1 and nums2, and this is what Leetcode was referring to nums3. And we have to return bitwise XOR of all integers in nums3. So we have to perform bitwise XOR on these numbers as well. We know that when we perform XOR between different numbers, if a bit appears odd number of times, it remains set. But if a bit appears even number of times, then it cancels out. So here we can see that at 0th position, number of ones are 7. So in the output, the bit at 0th position will be set. Then at bit position 1, number of ones are 6, which is even. So we will set 0 here. Then at bit position 2, there are 3 set bits, which is odd, and XORing between them will give us 1. And finally at bit position 3, there are 3 set bits again, so XORing between them will again give us 1. So then our answer becomes 1101 in binary, which is 13 in decimal. Now in terms of solution, the naive approach would be to compute the XOR of all pairings between elements of nums1 and nums2, just as we did in the example walkthrough. So we iterate through each element in nums1, and then for each element in nums1, we iterate through each element in nums2, and compute the bitwise XOR of the current pair, and update our result by XORing it with the computed value. And in the end, we will return the final result after iterating through all the pairings. Note that we don't have to create a nums3 array, as we can perform the XOR operation on each pair as soon as we generate it. The time complexity of this approach is O of m into n, where m is length of nums1 and n is length of nums2 because of the nested loop, and the space complexity will be O of 1. And if we try to submit the code based on this approach, we will get time limit exceeded. And now the question is, how can we do better? To answer that, let's again see the example and observe it more closely. When we perform the XOR operations, we see that elements in blue appear even number of times, like 2 appears 4 times, 1 appears 4 times, and 3 also appear 4 times. This is because size of nums2 is 4. But how can that help? This is where this XOR property gets handy. That is, XOR of a number with self is always 0. The reason this holds true is that at a bit level, XORing a number with itself cancels out all the set bits, resulting in 0. Therefore, if a number appears even number of times, it will cancel out. However, if a number appears odd number of times, it remains in the final result. For example, let's take a generic number a that appears 2 times. So a XOR a will be equal to 0. But now let's take the number b which appears 3 times. Then b XOR b will be equal to b, because we can cancel out 2 of the b's and only one b will remain. Now coming back to our problem, suppose nums1 has elements a, b, c and nums2 has element x, y. I'm using these alphabetical variables to clearly illustrate how often each number occurs and how can we cancel them out based on their frequency. So this is how the pairwise XOR will look. Again, I'm using blue color for nums1 and green color for nums2. So for element A, we will perform A XOR x and A XOR y. Similarly, for element B, we will perform B XOR x and B XOR y. And for element C, we will perform C XOR x and C XOR y. And now we will XOR these XOR pairs. So what will be the XOR value here? So if you notice carefully, A, B, C's occur even number of times, so we will cancel them out. And when it comes to X, Y and Z, they appear 3 times, but 2 of them can cancel out, so only one of them will remain. So our answer will be X XOR Y, which is coming from XOR of nums2. So here we observe that nums1 had odd length and nums2 had even length. And when we perform the pairwise XOR between nums1 and nums2, elements from nums1 appear even number of times. So because of this, they cancel out and only the elements from nums2 remain. Similarly, if we reverse the scenario with nums1 having an even length and nums2 having an odd length, then we will see only the XOR of the elements of nums1. So the key here is, if an array has an even length, when we perform the pairwise XOR between the elements, the other array's elements will occur even number of times. So continuing with our cases, if both the arrays are of even length, for example, nums1 has 2 elements a and b and nums2 have 2 elements x and y, then the elements from both of them will occur even number of times, cancelling each other out, and our result will be 0. And if both the arrays have odd length, then all the elements from both nums1 and nums2 will remain in the final result. For example, if nums1 is abc and nums2 is xyz, then our answer will be bitwise XOR between the elements of nums1 and nums2. Now our approach will be, if size of nums1 is odd, then we will include all the elements of nums2 in the result. And if the size of nums2 is odd, then we will include all the elements of nums1 in the result. And now the time complexity reduces from O of m into n to O of m plus O of n, where m is length of nums1 and n is length of nums2, because in the worst case, both the arrays may be of odd length. And in terms of space complexity, it is still O of 1 because we are using some variables here and there. So now let's jump into the code part. First, let's initialize our answer to 0. This variable will hold our final XOR result as we process the arrays. And note that initial value of 0 is a safe choice because x XOR 0 is equal to x. Since at the binary level, 0 has all the bits equal to 0. Hence, all the bits in the x will remain unchanged. Now first we will check if length of nums1 is odd. If it is, then we will iterate through all the element of nums2 and XOR with our answer. Similarly, we check if length of nums2 is odd. If it is, then we will iterate through each element in nums1 and XOR the elements with the answer. And finally, we will return our answer. Now let's submit this code. Cool. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.